Hello guys, welcome back to my YouTube channel. So in this video we are going to see mathematical foundations for computing probability and statistics, that is covariance and correlation of joint probability distribution. Welcome to this presentation of covariance and correlation of joint probability distribution. Today we will explore these important concepts and what they are crucial for understanding data analysis. Covariance or correlation are two measures that allow us to analyze the relationship between two or more variables. By understanding these measures, we can gain valuable insights into the patterns and trend in our data. Okay, so now let's see what is joint probability distribution. It is a way of analyzing the relationship between two or more variables by looking at the probability of their occurrence together. In other words, it allows us to determine the likelihood of multiple events happening simultaneously. For example, if we wanted to know the probability of rolling a 3 on one die and 4 on another, we would use a joint probability distribution to calculate the probability of the specific outcome. Joint probability distributions are useful in many fields, including finance, economics, and social science. They can help us understand the relationship between variables, such as how changes in one variable affect the probability of the another event occurring. For instance, in finance, joint probability distribution can be used to model the risk and return of a portfolio of assets. Covariance. It is a statistical measure that quantifies the linear relationship between two variables. It measures how much two variables change together. It can be positive or negative depending on whether they move in the same or opposite directions. Understanding covariance is important in data analysis because it helps us identify patterns and relationships between variables. For example, let's say we have two variables: the number of hours studied for a test and grade received on that test. If there is a positive covariance between these two variables, it means that as the number of hours studied increases, the grade received also tends to increase. On the other hand, there is a negative covariance. It means that as the number of hours studied increase, the grade received tends to decrease. Properties of covariance. Covariance has two important properties, sign and magnitude. The sign of the covariance indicates the direction of the linear relationship between two variables. A positive covariance indicates a positive relationship, while a negative covariance indicates a negative relationship. For example, if we observe that as one variable increases, so does the other, we have a positive relationship and a positive covariance. Conversely, if we observe that as one variable increases and the other decreases, we have negative relationship and a negative covariance. The magnitude of the covariance indicates the strength of the linear relationship between two variables. A larger covariance indicates a stronger relationship, while a smaller covariance indicates a weaker relationship. However, it is important to note that the magnitude of the covariance is not standardized and depends on the scale of variables. Therefore, it is often more useful to use the correlation coefficient to measure the strength of the relationship between two variables. Correlation. It is a statistical measure that quantifies the strength and the direction of the linear relationship between two variables. It ranges from -1 to +1, where -1 indicates a perfect negative correlation, 0 indicates no correlation, and +1 indicates a perfect positive correlation. To understand correlation better, let's consider an example. Suppose we want to analyze the relationship between the number of hours spent studying and the grade received on a test. If there is a positive correlation between these two variables, we would expect to see higher grades for the student who spent more time studying. On the other hand, if there is a negative correlation, we would expect to see lower grades for students who spend more time studying. By understanding the correlation between these two variables, we can make informed decisions about how much time to spend studying in order to achieve our desired grade. So now let's see properties of correlation. Interpreting correlation coefficients requires an understanding of their magnitude and sign. Magnitude refers to the strength of correlation, while sign refers to the direction of the relationship. For example, a correlation coefficient of minus 0.8 indicates a strong negative relationship between two variables, while a coefficient of 0.3 indicates a weak positive relationship. The sign of the coefficient indicates whether the relationship is positive or negative. A positive correlation means that as one variable increases, the other variable also tends to increase, while a negative correlation means as one variable increases, the other variable tends to decrease. Applications of covariance and correlation. Covariance and correlation are powerful tools that have a wide range of practical applications in many fields. For example, in finance, these measures can be used to analyze the relationship between different stocks or other financial assets. By understanding the covariance or correlation between these assets, investors can make more informed decisions about how to allocate their portfolios. In economics, covariance and correlation can be used to analyze the relationship between different economic variables such as GDP and unemployment. By understanding the strength and direction of these relationships, economists can make more accurate predictions about the future state of the economy. Limitations of covariance and correlation. While covariance and correlation are useful measures for analyzing the relationship between two variables, they do have limitations. One major limitation is that they only measure linear relationships. If the relationship between two variables is non-linear, then covariance and correlation may not accurately capture the true relationship. Another limitation is that covariance and correlation only measure that strength and direction of the relationship between two variables. Just because two variables are correlated or have a high covariance does not mean that one variable causes the other. There may be other factors at play that influence both variables.